let's talk about zeros of a polynomial function and continue on in section 3.2. And zeros of a polynomial function, if f is a polynomial function, then the values of x for which f of x is equal to 0 are called the zeros of f. These values of x are roots or solutions of a polynomial equation f of x equals 0. Each real root of the polynomial equation appears as an x-intercept of the graph of the polynomial function. Okay? Go to example 5. Find all the zeros of f of x equals x to the third plus 3x squared minus x minus 3. What we're going to set the polynomial function equal to 0. So we're going to set this equal to 0. 0 equals x to the third plus 3x squared minus x minus 3. We're going to solve this. I'm going to go back to, if we set this equal to 0, so we can back to the left-hand side. I'm going to factor by grouping. This becomes 0 equals x squared, x plus 3. So I'm grouping these two first. These two second, I get factor on negative 1. So I get x plus 3. I get 0 equals x plus 3, and then x squared minus 1. So 0 equals x plus 3, x plus 1, x minus 1. This is the difference of two squares. Okay, so x is going to equal negative 3, negative 1, or 1. Okay, the zeros are negative 3, negative 1, or 1. And in my math lab, they're probably going to ask you to go ahead and type in instead of negative 3, negative 1, and 1. So zeros are negative 3, negative 1, or 1, and then my math lab will have you type in this. Personally, I like to go ahead and tell you that the graph passes through. So on the test, I'll probably ask you for the intercept. The graph passes through the points negative 3, 0, negative 1, 0, and 1, 0. And how to get these zeros here, because remember we set y equal to 0. Here's y equal to 0. So that goes through the point. So now we know a little bit more about the polynomial function. We can determine what happens at the end of this, the end behaviors of this function, or what happens at the end of the graph. We want to tell you what happens to the graph. It passes through these 3 points. Okay, so go ahead and pause the video, and on your own, go ahead and find the zeros of this polynomial function. Okay, so I went ahead and I factored, or set equal to 0, polynomial function is 0. Then I factored the right-hand side, and I got these 3 factors. And notice how this, when you get these 3 factors, you get x equals negative 2, and 2. Notice how this one occurs twice. We'll talk more about that later. So our zeros are negative 2 and 2. In my math lab, I'll just have you write this. But it actually passes through negative 2, 0, and 2, 0. So the graph passes through those 2 points. Okay. Go to example 6. Let's find the zeros of this polynomial function. So you get 0 equals negative x to the 4th plus 4x cubed minus 4x squared. And I'm going to go ahead and factor the right-hand side. I'm going to go ahead and pull out the greatest common factor. Pull out the negative, because the first term is negative. Pull an x squared. So I get x squared minus 4x plus 1. Plus 4, Okay, if I pull this out of here, I get this out of here, I get that, and this out of here, I get plus 4. And then I'm going to go ahead and factor this using trial and error. I get x minus 2, x minus 2. And when you multiply this out, you should get that back. Okay. Set each one equals 0. So if I set this equal to negative x squared equals 0, divided by negative 1, I get x squared equals 0, x equals plus or minus square root of 0, x equals 0. I get x equals 0, x equals 2, and x equals 2 again. This happened twice. We'll talk more about that in a minute, but it occurs twice. So our zeros are 0 and 2. Okay. Again, my math lab will ask you for this. Just those 2 zeros. And then the intercepts are go back to, let's go ahead and have you do one on your own. So go ahead and find the zeros for this, and we'll go ahead and look back at example 6. So go ahead and pause the video and do this one on your own. Okay, so on your own problem, I got the zeros are 0, negative 2, and 2. And I went ahead and gave you the actual points for the x-intercepts. Okay, let's go back to example 6. In example 6, I had this problem here, f of x equals negative x to the 4th plus 4x cubed minus 4x squared. And we got x equals 0 and x equals 2 for our zeros. So go back to example 6, which is right here. We got x equals 0 and 2. But really, if we look at example 6 carefully, go back to example 6. If you look at this carefully, and I'm going to go ahead and do this in red, this x here, we actually got x equal plus or minus 0, because 2 values of 0. It really, 0 actually occurred twice. So 0, x equals 0, x equals 0. We have a plus 0 and the minus 0. This actually occurred twice. And this x equals 2 actually occurred twice. So that's interesting to look at. So we got x equals 0 and x equals 2, but both of them really occurred twice. What we really got was x equals 0, x equals 0, x equals 2, and x equals 2. We knew that x 0 and 2 are both zeros with multiplicity of 2. What that meant was that we each had 0 occurring twice, multiplicity of 2. Okay. This is an even multiplicity. Okay. So what the graph looks like, if you look at this carefully, if you have a multiplicity that's even, here's a 0, here is a 0, 0 and 2. Okay, so 0, 0, and then 2, 0. If you have a multiplicity that's even, what's going to happen to the graph is going to touch that x-intercept, it's going to bounce right back off. It's going to touch it, and then bounce right back off. Touch it, and bounce right back off. That's even multiplicity. So let's go into the real multiplicity, and we'll kind of see more examples of this in just a minute. If you have a 0, and it has even multiplicity, what that means is that it occurs twice, or it occurs 4 times, or it occurs 6 times, and so on, an even multiplicity, the graph will touch the x-axis and turn around at that 0. If you have a 0 and it has odd multiplicity, it only occurs once, it occurs 3 times, it occurs 5 times, and so on, the graph is actually going to cross the x-axis at that 0. It's going to go through that x-intercept. Okay, so let's go ahead and look at an example. Let's find all the zeros of this function and then give the multiplicity of each and take whether it crosses it or goes through, crosses the x-axis or touches the x-axis at each 0. Okay? So let's look at our zeros. Well, here we have a 0 here, and as I said, and again, I'm going to go ahead and do this long way. 0 equals 1/2 x plus 1, 2x minus 3 squared. So let's do that real quick. I'm setting it equal to 0. It's done all the work for me. It's actually factored out the function for me. So what I really have here is I really have 0 equals 1/2 x plus 1, and this is 2x minus 3, and then 2x minus 3. My zeros are negative 1, okay, that's right here. And then if I set this equal to 0, off to the side here, I get 2x equals 3, divided by 2, x equals 3 halves, and 3 halves, because this would make that 0, but this one has a multiplicity of 2. Because it occurs twice. I have 3 halves here and then 3 halves here. This has a multiplicity of 1. Because it only occurs once. This negative 1 only occurs once. Okay. So what happens here is what we know is that we have the zeros are, well, not zero, but the graph crosses. Crosses. Let's say the graph, so I can get this a little more clearer. Okay, so we know we have multiplicity of 1 here. So this 0 is going to be negative 1, 0. That's the x-intercept. And this one's going to be 3 halves, 0. Okay, but this has a multiplicity of 1. Let's go back to the rule here. If it's an odd multiplicity, it's going to cross the x-axis at that 0. Okay, this is an odd multiplicity. 1 is odd. So at negative 1, 0, the graph crosses it. So the graph crosses at negative 1, 0. And this has an even multiplicity, so it's going to actually touch the graph, touch the 0. So the graph touches 3 halves, 0, and then bounces back. I guess the better word would be, and then turns around. So here, if I were to actually look at this visually, I'm going to give you a little sketch of what would happen. It's going to happen at this 0 right here. Negative 1, 0, it's going to go through it. So it's going to go like this and go through it. It's going to go through it. At 3 halves 0, which is right here, it's going to touch it and come back. So it's going to either come here, come down here, and then come back up, or touch it here and then come back around. It doesn't go through. It doesn't go straight through that point. Okay. On your own, go ahead and find the zeros of this function and give the multiplicity of each, and then tell me what happens at each 0. Go ahead and pause the video and do that. Okay, so on your own, I went ahead and did the problem. I went ahead and found the zeros. The zeros are negative 1 half and 5. This 0 has a multiplicity of 2 because it's going to occur twice. You have this factor twice. That means that 0 is going to occur twice. This 0 is going to occur 3 times because it would be 3 factors of x minus 5, and then a multiplicity of 3. Even multiplicity, odd multiplicity. So this 0 of negative 1 half 0 is going to have the graph touch it at negative 1, 0 and turn around. It's going to bounce back off. And at 5, 0, the graph is actually going to cross or go through that point 5, 0. Another thing we talk about is something called turning points. And look at this graph right here. And turning points is when it goes from increasing to decreasing or vice versa. It goes from increasing to decreasing or vice versa. Okay. So if you look at this graph right here, notice how it has a turning point right here, and here, here, and here. Notice that this graph has a degree of 5. It tells you the degree of 5. And you have 1, 2, 3, 4 turning points. Okay. So in general, if f has a polynomial degree n, then the graph has at most n minus 1 turning points. We're going to look at that. So we're going to look at that more in depth later on. But if you have a degree of 6, you should only have 5 turning points, and so on. At the end of this, I'm getting to my end of the time.